Alright, I hope people can hear me. So I guess we can start. Hi everyone, hope you're doing good. I don't know if some of you participated in the Julia hackathon a bit earlier. Hope you had some fun. Yeah, sadly had a bit of research. Well, I had just some research to do today, so couldn't join that much. So first thing I'm gonna do is I think I have a pull request to finish here on this repo that we're gonna work on. Oh no, it's done already. Objective function, yeah, wonderful. Okay, so this is HiGHS. I think it's pronounced like this, HiGHS.jl, which is a wrapper for the HiGHS linear optimization solver, which is fairly new, open source, and that's its big quality compared to others. It's so it's open source, fairly performant. So it could replace for some use cases CLP, Soplex, and maybe others. Right. So yeah, I'll check. Where's master? I think I can delete the branches I have around, which are variable values. I think. Nope. That's, I don't know. What is this one? Am I test? Nope. I think I should be able to do this objective. Really? I think objectives. Yeah, absolutely nothing. So I don't know why it doesn't recognize that the objective is now fully merged. Yeah, I have lots of branches trailing around. Var names was also from yesterday. Alright. Better already. Yeah, what I'm doing here is contributing to the wrapper of the solver, not the solver itself. I'm not smart enough to develop all the underlying implementations for the simplex, the interpoint method, and so all I'm doing is just translating the internal model or the internal representation of an optimization problem for the solver into something that's accepted by math-out interface, and making it as convenient as possible and fairly performant if we can. Right. Okay. So in the meantime, so linear optimization can be a bit tricky. So if you have questions, don't hesitate. Yeah, I guess I start now. I was not planning on doing a stream, so I'm not that early on this. Okay, so what is in our wrapper? We have different things here. First part here is the generation folder, gen folder. So we use this to generate some parts of the wrapper automatically from the sources of HiGHS. Okay, so we'll see that in a minute. So this is its own project with a manifest and a project toml. Okay. Second part is so the source, and in the source we have C model is all about memory management of the C objects or the native objects. So when it gets destroyed and so on, because you don't want to mess up your objects. So have some objects being dereferenced but not freed on the C side, or the other way around. Some objects that are freed and deleted, but you still have a reference to it, and so you have a dangling reference that points to nothing, and you end up with terrible things. That's the joy of working with some native solvers anyway, so you always have this kind of problem of wondering where is the memory, where did it go, what's happening where, and so on. So the thing I wanted to do, let's start a new branch, and if you have questions, just ask along. We can explore a bit more on some of the things. This is not a formal presentation on HiGHS itself, but I can answer questions on the way we wrap the solver and so on. So I've been working a lot with Binary Builder in the last, let's say, days, weeks, and helped a lot by the team from Binary Builder, lots of them, Moses especially. And yeah, Moses has been doing some streams on Binary Builder itself if you want to check it out. Otherwise, so let's branch, yes, inequalities. Oh no, I already have a branch inequality. Merge master, yeah, of course. Let's start with fixing some conflicts. What better way to start a stream? That we don't need. Cool. Okay, that seems fine. And the other is test MY wrapper. Okay. Here. Well, that wasn't too bad for a merge conflict. I'm even surprised that the merge couldn't be done itself. I'm just gonna test the chat to see if both YouTube and Twitch receive it. Yeah, it seems fine. Okay, cool. Oh. Okay. So so start with that. Fix conflicts. Yes. Okay, now we can start with some real things. So what I wanted to do is, let's say bridge, but not really bridge some constraints. So first, let's see what does the solver support. So we can check the wrapper here, and the key part of the wrapper is this API part. So this is all generated by Clang, and so this is basically wrapping the whole interface of the native solver, of the C++ based solver, and generating corresponding Julia functions. So you call it with, so you call it, and this creates your object. So usually you have to, so what it does is doing a C call, so calling on this C library here, so on this dynamic library, calling this function and passing it this. No, that's the type of return, and that's the types of the arguments, and then that's the arguments here. And you have all your types defined like that. So this needs to be some C compliant types, which means you have some fairly poor semantics. Meaning, if you have an object that you need to get modified, you pass it as a pointer. If you have an array, you pass it as a pointer. If you have anything, you pass it as a pointer. So yeah, in the end, you need to check the documentation to see what exactly pointer void is in that case, or pointer double is in this case, and so on. So what I want to do is work on the columns here specifically, and I don't want that. So this is to add a column. So when you add instead of adding a variable, as you do in MATLAB interface, you add a column, because the abstraction here is not any optimization problem, it's really specific to linear problems. And if you're solving linear problems, well, if you imagine your AX matrix, then a new variable or any variable is a column, and any constraint is a row in this matrix, okay? And so therefore you can you can add a column directly, which is not only adding a variable, but you can add your variable with directly a lower bound, an upper bound, a number of non-zeros. And so you can, if you have some constraints that already exist, then you can add some indices and values to these constraints. So meaning you can add a new column with some coefficients on existing constraints. So this can be great, for example, for column generation. This is the perfect use case. But in our case, when we're adding just variables and we're adding them without any constraint, it means we have to add it with a cost of 0. Oh yeah, and you also have a cost when you add the constraint up front. So meaning when you add a column, you can, by default, if we just add a variable without knowing anything about this variable, then we just add with a cost of 0, lower bound of -infinity, upper bound of +infinity, and this 0, and then null pointers. Okay. So you can also add multiple columns. That's classical things, and yes. So change column cost, so we can change the cost only, but we cannot change the bounds themselves. So if you want to change the bounds, oh, you can. Yes, no, you can change the bound, sorry. What you can't do is just change one bound. And what often happens is that you have a column that is constrained only on one side, meaning, for example, you have your column X and it has to be positive. And in that case, you have a lower bound, but you don't have an upper bound on this column. And this means, so this is fine when you want to add, when you add it, but if you want to change the less than or equal, then you need to get the two bounds. You need to get the two bounds, change only the lower, and leave the upper as is. Okay. Alright. I'm not sure how clear this is. I hope it's not too bad. Otherwise, don't feel free to ask questions. But yeah, so what I want to do in this stream is being able to support not only interval constraints, which is the case here, because every time we speak about a column or a row, we have a constraint on it, it will always be a lower and an upper bound, and we have to manipulate both at the same time. What I want to do is being able to change only an upper or a lower bound. And the same thing here, so if you want to change multiple bounds, you can, but you always have to change both the lower and the upper bound. Alright, so what does the MOI wrapper? So I use MOI for opt interface. Don't try not to get confused, otherwise ask. But so this is the basic file where the magic happens, let's say. So when we define an optimizer, which is the standard structure used by math opt interface, and this will wrap our model, which is a HiGHS model, so more or less a pointer to a native HiGHS object on the C side in the dynamic library. Alright, so I'll go to interval directly. So no, that's not interesting. Yes, so here I'll start with a single variables because I feel that like this is easier. So I can add a constraint of single variable in an interval here, and I just change the bounds here, and this is easy because I'm provided with an interval here. Okay, so I don't need I can rewrite both a lower and upper here. But if I'm provided with only let's say we'll start with less than, then I need first to fetch my column with the two bounds, and then from this column, so yeah, I'm gonna keep the upper bound and I'm gonna reset the lower bound. So I have my variable index here, and then I'm gonna have to fetch my column in some way. I don't think I have defined any method for that yet. I have only the wrapper thing. Call by range. Call bounds. No, so change call bounds is only this one, and then get call. Yes, get call by range. I think I'm gonna have, this is the best one I'm gonna have here. So it's a bit stupid, but I'm gonna have to get the calls by range with only one column, which would be the column I'm interested in. So I'm just gonna copy the signature here to use it there, because I know I'm gonna have to use it at some point. Alright, so first thing is getting my column. So I have my variable index, so that's good, and get called by range. So HiGHS here, so it's gonna be my pointer to the HiGHS object, and that would be model inner. So O is the math opt interface optimizer structure. Model is the managed object, so which has some logic on garbage collection and so on. And then inner is just really a row pointer that I'm gonna pass to my to the HiGHS library. So from call is easy. It's gonna be my var index, and I hope this is included and here excluded because I'm just gonna pass the same here. Num calls is what's, I'm also gonna check the types. Why don't I have a type for this? So I'm also gonna take the signature here to have an idea of what is expected. Alright, so this is my pointer. We did it. That's my var index, okay. Numcall is a pointer. Okay, so that's so this would be the number of columns that are written, and in that case it should always be 1. So we'll define it as a reference to a cint and define it at 0 first, And after we call this method here, or after we call this remote function to a HiGHS object, it's supposed to be just one. One because we're getting exactly one column. Okay, cool. So that's done. The cost, we don't care about the cost, so I feel we could just pass it a null pointer, I hope. So it's C null, and it should not write it. So it's normally in HiGHS itself, it checks did the caller pass me a null pointer. If that's the case, I'm ignoring this argument. And lower and upper, so these ones we will want. And basically here it's just gonna be one number because we have just one column. So lower is gonna be, oh wait, we don't care about less than, so we don't care about the lower here because we're gonna rewrite it anyway, but the upper we want that. So the upper is gonna be rough. Oh wait, no. If we're adding a constraint, it doesn't mean that the former constraint is erased. So it means we will still need that, I think. Okay, imagine you first add a constraint, x is smaller equal to 3, and then you add another constraint, x smaller or equal to 4. And in that case, let me think. In that case, it means this one is not completely ignored. I'm not sure. Because it's going to be rewritten here. But yeah, anyway, if we smaller or equal to 3, yeah, that's less than, oops. So small or equal to 3, and then if we set small or equal to 4, it means the one that is kept is the small or equal to 3. And thus, this one will be ignored, so the new one will be ignored. I hope that makes sense, and I hope this is how other libraries do it, meaning the other wrappers. So it means we're gonna have to pass it 2 pointers for lower upper. Number of non-zero, this is gonna be a reference cint non-zero, nz, just nz. That was just an example. Right, number of non-zero we did. That we're gonna ignore here, so this is gonna be null pointer, null pointer. So lower upper is done. This is gonna be C null, C null, C null. Okay, cool. I think we have everything. Okay, so we can now get calls by range with just one column in the end, and out of this column we're gonna get one lower and one upper. This should probably be in this should be in its own method, like get constraint with a constraint index. I'm not sure how MathOpt interface calls it again. Oop. Oh, caps lock. So, and we want get constraints. So if we have a constraint index, let's say, constraint set, yes. A constraint attribute for abstracted object used to define the constraint, okay. And my.constraint index. Constraint index is indexed by FNS, okay. So I feel like we will need this get constraints. Oops, there's some training spaces here. Okay. Yes, so first thing I'll do is write this moi.get. So moi has this weird syntax, like very Java-like, where you have this .get method that does everything and anything, and in that, so you pass it the optimizer you're getting something from, you pass it the thing you want to get, which will be CI a constraint index of type so FNS, so it will be moi that single variable, and the set will be moi that less than or interval. Yeah, we'll start with interval, that will be easier. And that's it, yeah. I'll just check that I didn't mess up my, yes. Constraint index FS, okay. I think that's correct. Constraint index single variable. Okay, and one convention is that the index of a single variable constraint is always the same as the variable itself. Oops, no. Okay, so that's a valid type. Oh, that's float 64 here. And this needs an integer, I think. No, let's see what it needs. Yeah, just a value, okay. So here we are getting oh yeah, right, so we pass it this constraint index at the end, and what we get here is constraint set. Yes, constraint set out of this. Or we could get the constraint function, but it's not very useful. The way we can do it. So the constraint function, in that case here. So we said that the constraint function needs to be an moi single variable, and the index is the same as ci.index. Ci value. Okay. Return. Now the constraint set. So if we want to get a constraint set for a given constraint index, that's going to be this with an interval. Now we need to do all this logic here. Get called by range. Okay. So out of this we get the lower and the upper. Why do I have trailing spaces here? Normally, so the number of column is supposed to be 1. Maybe a 1 or error. I don't think we can have much more informative here than just a plain error. And the error is going to be unexpected HiGHS state, maybe. Number of column should columns be 1 is for valid range and is that. Okay. So we now know that we got back one column, which is what we wanted in the first place. And then so it means we computed our lower and upper here. And what we return from this is a constraint set. What are we supposed to return? Oh, we're just supposed to return the set which is an MOI interval with lower and upper. And we return that. Okay, so now that we have this logic in place, we can just reuse it here in the so instead of having this whole machinery there, we can just recall this one. So get o MOI dot constraint set, and the CI is going to be constraint index with our given variable. I think we will have to return this CI anyway, so we'll create it right away. So it's sg dot if we have a single variable, what are the names? So single variable we created with a variable index. Let's say 0 here, so this is more or less valid. And then the names is variable dot value, okay, not the index. CI dot variable dot value. So sg variable dot value. I hope this is not too confusing about what's going on here. So I'm just MOI is a weird beast in some sense. It has some very particular machinery. It's not the most idiomatic Julia code in some way. Like all this get here is a very bizarre way to proceed. But it's an interesting part of the design space of Julia programs, I'd say. So we have created this constraint index here, which has the same variable index, the same index as the variable index that corresponds. CI, so we get this, and this is returning us the set, or the interval set, and then if interval set if interval set upper, so if the upper of the interval set is we'll write it the other way. If set dot, if I have a less than, what's the thing called inside upper? Okay. set.upper is smaller than interval set upper bound. So in that case, it means we need to modify the bound. Otherwise, maybe we should add a warning because we're just discarding a constraint. What is the best way to proceed? Yeah, good question. Because otherwise, here this means we want to add a constraint that will not be activated, but maybe at some point we want to delete the current bound. We don't know. And in that case, should something be done? Should we keep all the possible bounds, all the possible constraints that have been added, and then get the possibility of removing them? I'm really not sure. Well, let's not do anything for now. So it means if you add a bound and it's not active because you already have a bound that's tighter, the bound would your new bound would just be ignored. So here, this means we have to replace the bound, and so we will have to call this one here. So change call bounds with model inner. Variable index is, where's my variable index from? Yeah, variable index is my SG variable value. And conversion to cint. Nope, that's not there, it's here. Cint. And then so here we have the set lower is actually the interval set dot lower, because we didn't modify this. And then the upper is set dot upper, yes. Okay. Yep. And we return out of this I don't know why I created this set interval. Then I need to create my other one, CI, and this is, oh, here importantly this has to be a concrete type, meaning I need my float 64 here. And here my new CI, my new constraint index by itself is going to be so single variable, but less than, and then SG variable value, we can keep that. And we have to return, or we can just return it directly. So we need to return this constraint index when we add a constraint. That's the convention. Okay, so we could go directly to doing the greater than, or we could just test for now. Let's play it risky. Let's not test for now, we'll test afterwards. I guess the narrator voice now could say this was wrong. Greater than. And so we won't have many things to modify here. So set dot lower greater than interval set dot lower. So here it's set dot lower, and here interval set. Upper, because the upper didn't change, and then here we are returning our greater than float 64 variable value. Okay, so this was not just for fun, this was also a feature that was missing to use some extended tests that are provided by MOI. For this, you need to be able to add some simple bounds, which was not the case for a moment. Let's add some tests now. Question in the chat. I'll just repost it because it's a good one and people would like to see it, I guess. So why do I have underscore equals C wrapper blah? It's a good question. It's a convention I kind of kept when I ignore some return type. Some languages force you to ignore it explicitly when you are returning something from a function and you just discard it. So in that case, what is returned is a boolean normally. So since it's passing through C, it becomes an integer. But the boolean here is saying, did that go well or not? And here I'm just discarding it and considering if I have an error and I just have a boolean, it just brings me nothing to error out for nothing. But still in the code, I like to keep that for a moment to say, hey, watch out, here I'm normally computing a value and it should be used for something and just discarding it explicitly. Yeah, I think I kept this convention from developing in Go before, a long time ago, well, some years ago. And so because of that, I'm trying to keep explicit when I'm discarding a value. So the first thing I want to test is this one here, which is for an optimizer that's defined getting a constraint set. Yeah, getting the constraint set for a given constraint index of variable in interval. Oh, I zoomed a bit too much, I think. So Eric, I hope I answered your question. I'm not sure if you developed in Go or if you've seen some Go code, but yeah, I think you get a warning when you don't explicitly discard a value with an underscore or wildcard. Test here. Alright. I'm gonna reuse some tests already done, I guess. Variable names. Model empty. Yeah, that's not the thing I wanted. Yeah, I'm not sure that many languages have this convention of explicitly discarding things, but I like it because it's saying this function is normally a bool and I'm just not using the result, but normally you should be checking something out of it. Okay, I think I'm gonna use the beginning of this here to create a new test set, and this is gonna be what is gonna be the name for this? Interval and bounds. Column, interval, and bounds. Yeah, I'm gonna keep this. This is useful for test set to have a very short, compact version of what this test set is doing. So in that case, it's a small problem maximizing x1 plus 2x2, subject to both variables bounded between 0 and 5, and then variable 1. Yeah, this is a linear constraint, but we're not gonna discard it. So x1 and this is my constraint index ci interval 1, and this is my constraint index ci interval 2. So when we add when we add a constraint variable to an optimizer, this is returning both the variable index and the constraint index. First thing we can do, I guess, is test that. So this dot value equal x1 dot value, and then same thing for the 2 here. I could just even test it directly, or no, I'm gonna run my test in a clean way. Okay, I'm gonna leave my, so I won't need that much, I think. So column intervals and bounds, okay. So while my tests are running, so this was a basic test here saying normally by the convention MOI has the index of a single variable in a constraint is supposed to be the same as the index of the variable itself. And then, oops, not here, what I want to do is test this function. So get, so my optimizer is going to be the same. I'm going to get the constraint sets of ci on of the first one, the first single variable, and this should, and yeah, and this should give me interval set 1, and then same thing for the 2, let's say. I don't need to copy everything for the 2 variable, I think. So interval set 1, so test interval set 1 dot lower equal, yeah, I think we can use strict equality because we're supposed to have just passed the 0 and 5 to the solver and returned it back. There should be no transformation, arithmetic or anything. So in that case we should be able to use strict equality. If it blows away, you know where it was, and the upper is supposed to be that. Okay, in the meantime I'll check my test. I guess this has blown away already. Yes, absolutely. The broken one should be fine. Yeah, there are bugs that need to be fixed, but so what is broken there? Getting objecting value. This is curious. Okay, I have errors where I was not supposed to have errors. Interesting. What is this one? Minus. Getting objective value. So what was wrong here? So we are minimizing here, okay. Oh yeah, I think we need to empty the optimizers here. I guess that will make it a P. I'm afraid I'm gonna have these termination. I need to open it with them. This is one of the bugs I have in my editor. When it loads at different points, I think it usually does it. Oh no, okay. I thought this would add some weird line ending. So we already have, yeah, I'm always opening way too many things at the same time. Nope, still an error. Column intervals and bounds. Okay, we have an error here, which is good because this is where we're likely to have errors. Model like of type HiGHS optimizer does support accessing the attribute constraint set. Oh yeah. Okay, I see exactly where it is now. So here we are defining that we can access the constraint set. So we could wonder why can we not? Well, again, the way math opt interface works is very particular. It's like extending the dispatch or doing its own dispatch, and so meaning you don't have only to define a function, you also have to explicitly say that you support a function by adding this supports thing, equal true. And so yeah, you have a default that's activated if you don't support something. So now it should be fine because I explicitly said that I supported it. So yeah, if you want the I'm gonna shamefully reference myself. If you want a reference on this, let's see, in my recent blog post, so this is my website, I think I have a recent post on MathOpt interface, and more precisely on yes, bridges as an extended dispatch system. And this is some random thoughts on the bridge system that exists and MathOpt interface in general, and how it relates to the dispatch system in Julia, because it's similar but doing it in a different way. Okay, we still have an error. So constraint set, constraint index, single variable, interval. Okay, yeah. We have, I think we need float 64 here. I'm not even sure we need the support then. Let's see if it works without it. Okay, we didn't break the first test, that's great. Yes, but we still have single variable, interval, so we do need the second one, it seems. Which is a bit of a bummer. We could maybe subtype it here, like say 4 subtypes of my interval. Yeah, one thing I should do at some point is also reduce the verbosity of a test, but for now it's nice to have because I can understand what's going on under HiGHS. Wait, what do you want now? Constraint sets, HiGHS optimizer, my constraint sets, constraint index, variable, MathOpt interface, interval. We have exactly that. Constraint sets, constraint index. Oh no, we don't have that, no. Wait, oh yes, this was I just modified, I fixed the constraint function thing, but not the constraint set one. C4, genius. Okay, in the meantime we can, I guess, modify our tests. Oops. Here, and so the other thing we can do is take the constraint function and so and the function is a single variable. Oh, still have an error. Okay, SG not defined. Where did I use SG? SRC wrapper 67. SG. Oh, that's what was that? What was that from? I'm not using verbal indexes. Oh yeah, it's a constraint index dot value. So ci dot value. Whoopsie. And in the meantime, so func dot how do I need an over Julia process open. Nope, not big enough. Import my stuff. Single variable. Dot variable dot value. Yes. Variable dot value equal no, or even I don't need that, equal x1. Yes, I think that's the problem of what I was typing at the moment. 39, and that's, yeah, where is stack trace? Oh no, it's a problem in my wrapper. 61 ci dot value. Oh, ci dot value is so I cannot convert. Yes, I need to construct a variable index from that, and then pass this to a single variable, which is a function. So one thing for people watching who are not familiar with MATLAB interface, MATLAB interface uses the concept of functions and of sets, which is not the same as the native Julia set and native Julia functions. A function is a transformation of some optimization variables, which are not the same thing as the variables in your program. It's variables from the optimization problem, and a function is a transformation of these, and they can belong in a set, which is not a collection but more a set in a symbolic sense. If I not define 248 func1, obviously easy fix. Oops, and HiGHS get calls by range, that's here, and yeah, this here needs the wrapper. So I define a submodule wrapper, C wrapper, to be more specific, that I'm using here. Okay, so we're getting now on the easy fixes, so I guess we're gonna see some green soon, I hope. Don't worry about the memory failure. I'm testing for memory failure, so I'm testing for corner cases here. We still have some errors. No method matching interval ref value and ref value. Oh, right. Yes, absolutely. This is 7.4 here, because these are references, and these were more or less pointers to values, because we wanted to get some values out of C, and we cannot do that except for pointers, so we have to dereference them here. Okay, it's a good thing to have written tests first and then try to see if things work. Otherwise, if we had just rolled along with other stuff, well, we would have found this ages later. This would not have been fun. Okay, cool, we're seeing green finally. So we can move forward. Do I have some other tests that I want to do here? I guess it's all good. So we're testing a constraint function, constraint set, and now I guess I want to go on this part, which will be I want to add a constraint I want to add a constraint of type less than, so a single variable less than this. And in any case, I'm going to return a value here. Okay, so let's dive in. So this will also be for renal test. So now we're going to add a constraint. Let's inactive. So we're going to add an inactive constraint, a useless constraint, so to speak. And this constraint is going to be our optimizer, a single variable with x1, and the set is going to be less than, we have to be less than 6.0. And here, since 6 is greater than 5, and we're saying we're already we have to be less than 5, and we're saying now we have to be less than 6, so this 6 needs to be ignored. So same thing, I'm gonna verify that CI inactive dot value, so this is the verb, has to be the variable dot value. And then I didn't get things, but I guess I'm gonna I can get a second time my constraint here and test that this has not been modified like that. So this will be a first test. Let's see if it blows up or not. So again, what we're doing here is we have initial bounds, so lower and upper bound on our variable x1. Then we add a constraint saying this x1 has to be less than 6, which is not useful because we already constrained to be less than 5. And so therefore it's supposed to be ignored. CI not defined. Great. Where is it not defined? SRC 79. Here. CI interval, obviously. And I guess it's going to be the same thing here. So yes, and then we're going to add a new constraint to that, which this time is going to be active, so it means it's going to update the bound. So first thing is going to be, we're going to do the same thing for greater than. So add a greater inactive. Greater than, and then it's going to be greater than -1. And again, by the same logic, greater than -1 is useless because we are already greater than 0. We're going to do it on x2 for a change. So it's going to be interval set 2 equal get, and that's CI interval 2, and then this is supposed to be unchanged. Okay, test passed. Now let's see with our greater than logic if it's all good or not. Okay, seems good. Cool. So that's great. We can move on to the rest of it. So we can now move on to the active to add some active constraints, meaning now we're supposed to change. We're supposed to really change the bound, meaning CI less active. Let's restrict the bound on x1 to 4, to be less than 4. And so this time we're supposed to update the bound. CI less active value, x1 value, okay. And now we are getting CI interval 1. Is this still? Yeah, this constraint index is still supposed to be valid because it still contains only the information of the interval. And now this is supposed to be 0, 4. Let's see what if it works. So bad thing now, it's if it's not updating the bound, we're not happy. So I hope it does work. Oh, it does. Wonderful. And now we're going to do the same thing for greater than. Again, we're going to do it on x2 for change. And we'll say greater than 4 for x2. CS greater active is same as x2. And interval set 2 is MY get constraint set of CI interval 2. And so this time it's going to be 4 and 5. Otherwise, I don't know if some of you have some random questions on JuMP, since we're going to have quite some time. Seven 274 here. Greater than. Oh yeah, of course. I forgot to change that. So like I said, yeah, if you have questions on JuMP itself, how it works, or mathematical optimization, just post them in the chat. I try to answer the best I can. I'm not an expert, I'm learning myself, but I'm starting to get familiar with some of it. Alright, so I guess we're good to go now. So this all seems to work. What we can do now is also get the constraint set and constraint function. I'm not even sure we need that. This supports here. If we don't need the method, better remove it than keeping it for nothing. All good, yeah, so we don't need that support here. So constraint function and constraint set over. So that's going to be much easier for, let's say, the less than constraint. Constraint function over single variable in less than. So that's gonna be exactly the same now. I think we can yes, here we are gonna type parameterize this, say S, we don't even need a name. So it's going to be a union type with my interval, my less than, my greater than. So we don't need to make copies. So for every one of them, since it's single variable anyways, this logic applies. So this means we don't need that anymore. And here, so getting the constraint set now on not anymore interval anymore, but less than. So in that case, I think we're gonna get because anyway we have to do all this operation, so we're gonna get the same thing, but for the interval, and then interval set. So we're gonna get the interval and just return one of the two bounds. So O is our optimizer, constraint set is constraint set. So yeah, I'm not sure what would be the best way to do it, but this get with all these arguments feels a bit boilerplatey sometimes. But again, I mean, Julia is a fairly young language, and it has been pushing some interesting boundaries in terms of the semantics and what you can express. So it's legit that we have some experiments in the way we organize code. So I don't think it's a bad idea in absolute. It's an interesting one for sure. Constraint index, and then here is ci dot variable dot value. Single variable. No, yeah. My constraint index. Index dot value. Interval. So we are getting the same. We're getting basically the same information, but instead of a MOI lesson, we get MOI interval. So this computing, this is getting us the interval set, and then we return the MOI not less than, and so it's less than an upper bound. So interval set dot upper. And then the same logic applies for greater than. So with this, and we returning MY greater than lower. Okay, let us test that. So first, have we broken any tests? We're gonna run this in the meantime, and here we will want to get the constraint set for these constraints that we added. So moi.get constraint set for this. So it's going to be a list set. And test list set well, is less than first, we're not returning an interval, and then let's set that upper equal 4.0. We're gonna do the same thing for the greater than. Okay, cool, we didn't break any tests in the meantime. Greater set, and it's gonna be on the CI greater active is a greater than, oh, MOI dot MOI greater than, and then the upper bound is supposed to be 5, I think. CI greater, nope, greater than 4. Wait, what? Ah, yeah, greater than 4. Oh, here it was less than 4. Okay, yes, less than 4. Here, greater than 4. And so it's greater than means lower. Okay, let's try it out. Oops. Less than 4 is a math opt interface greater than. Oh, of course. It'll be better. Copy pasting is the root of all evil. Cool. So we have something more or less working now. That's great. One thing I want to do is now bring the bigger tests in, and the bigger tests are the one from math opt interface themselves, so the test suite that they have. I couldn't use it up to now because we didn't have this capacity to add isolated lower or upper bounds on columns and rows. So we added the capacity on columns. So I think some tests from a math opt interface will be doable now. So a bit too big. CD micro test. Nope, that's in source test. So it might be a bit bizarre to have a test folder in the source file, but it's actually because the library math opt interface is providing a kit of tests itself. And it's in unit tests. Let's say variables. So what kind of test do we have here? Add variable, okay. Add variables, okay. Delete variables, I'm not sure we have that. I don't think we have variable deletion. Delete non-negative variables. At the dimension non-negative variables. Get variables looks like a good one. Okay. I wonder if I didn't have already something around. Let's start. I'm getting too many tabs. Nope. Test. Do I have something with config? Yes, here. So here I'm starting with some tests from math opt interface itself. I shouldn't have closed that. Yep. So we have, let's see, add variable, which I'm already no, I'm not testing add variables. I guess that could be a good start. Add variable, it's not like that. Yeah. Add variable. Okay, I think I should just split my screen on this. Hope it's not gonna get too small. Yeah, let me know if it gets too small. Oh, Julia, not something I see a lot of Twitch. Yeah, that's right. There's not yet that much Julia on Twitch. I don't know. Well, it's not that much of a mainstream language. I mean, if you're just working on JSON your whole life, I don't think you have much probability to encounter Julia. If you go to more computing-ish domains, then you get to see some Julia. But yeah, but these days there's been a lot of Julia on Twitch, on YouTube too. Lots of people streaming documentation work and so on. Variables. I think these should pass. And I think this. Yeah, that's right. I mean, definitely there's. I think there's been two phenomena. So the question or the remark is the increase in Julia streaming has been correlated with the COVID outbreak. I do agree. I think there's been two things. First is people have time that they didn't have before. Well, more than two things, in fact. So people have time that they didn't have before. Add variable not defined. Where did I use 182? Yes, okay, 182. It's not. 186. Add variable. Ah. Sorry, I'm just fixing this and then developing a bit more. Variable names seems fine. So yeah, about the COVID outbreak. So first thing is people have time, a bit more than before. For some of them, obviously not those who have family or other additional loads. So second thing is people want to connect a bit more. I mean, I'm fine working alone, but it's better to have some people to chat with about my work when I do it. So usually that would be the function of my office, which is not the case at the moment. And the last thing is, since more people are streaming, let's say, more casually than before, you have less professional streamers and people who have less, let's say, high quality content like me. And because of that, you have less of a barrier to get into streaming, and people get into it a bit more, and so you see more diverse videos than you would see usually. Normally you would have way more people, let's say professional streamers or half professional streamers, while you have, well, these days more people doing it very, very casually and prepared and saying, well, I'm just gonna work on that, so follow along if you want. Yes, I think that was the one that was this test that was failing before, that I wanted to add normally for variable names. So yeah, I think the nicest development about this is for the streaming part. Of course, the rest is very dramatic. Get variable not defined. Oops, yeah, more T. So I'll first empty this. No, this is emptied before. So of course, yeah, the rest of the situation is dramatic, but regarding streamings only, the best thing, the thing I appreciate more about this is the fact that the barrier to entry is lower, or is seen as lower by people, and so you have more diverse people streaming. I am keeping getting failures. Unsupported. Okay, yes. That requires here a constraint name. Interesting. Which I don't have. Okay, that's fair enough. Variable names I implemented though. Am I testing variable names? So what I cannot do is get variable here. Yes, variable names I'm testing first. So get variable, I still cannot do it. So for those who don't know, so this is the test kit for the unit test directly provided by MathOpt interface, so that when you develop a new solver, you don't have to reinvent all the possible tests to see if your solver is valid. You have a whole bunch of them already. So that's very nice. And yeah, you don't need, you can just plug your solver here and see what's working, what's not working. So I think this is getting fairly in fairly good shape. One thing I could do here is add constraint name support. The other thing I could do is just brute force, just so you can just say test my solver with everything that's here. And this could actually be an idea of, well, doing this could be an idea. What I'm gonna do is go on the CLP CLP, sorry, I'm gonna switch that to window here. CLP.jl, this might be a bit small. Okay, CLP, and from this I'm gonna check how do they go about testing CLP. So CLP is another linear optimization solver that's also open source and that has some restrictions. So that means that not everything will work, and that's great because not everything works on the solver I'm developing now, or the solver that I'm wrapping now. And this means that I could just see how they do it and try to just take the same test and assume that I should pass the same test as CLP. That would be a good limit. So that's unit tests, all of them, I hope. And this is testing not on the pure solver but on the bridge solver. So if you don't know what bridges are, I'm not going to terrify you by trying to explain it, because it's a fairly complex component of MathOpt interface that you really don't need to know about to use it. So what I wanted to do is, yes, let's set MYT unit test again. Alright, of course. Unit tests, bridge and config. So config we defined, and bridge will be, I hope I didn't close it. Yeah, maybe we should also use this dual objective value false in the config. And bridge is going to be, I guess I could just copy everything here. Cache is universal fallback on, wait, are they even testing CLP here? Okay, yes. So the CLP optimizer is here. So I'm gonna do this here, and I don't need const everywhere. Cached is gonna be caching optimizer. That's gonna be HiGHS.optimizer. Bridged is going to be my bridge model, so the bridge of a cache. Set is going to be bridge silent. So if some of you are interested in some of it, some of this, feel free to ask specific questions. I just don't want to go into too many details here. Okay, so this is going to fail miserably. What I'm interested in is knowing where exactly it fails, because I think we're getting on the fairly good path now, so we could be testing much of the MOIT tests. No, yeah, okay. MOIU not defined. Okay, that's a fairly easy one. MOIU. Just gonna copy that here. I'm not sure if I can shadow config in the local test set. We'll see. Okay, some errors. Unsupported attribute silent. Okay, well it's not a big deal. We don't need silent yet. Could be worse. Could have some serious errors. Unsupported silent. Oh, so there's that in 198. Ah yes, also here. Wait, it means okay, yeah, they set the cache to silent, then the bridge to silent. Okay. So I think now, given that my PC stopped and starting to hit a bit, the real tests have started. That's great. So yeah, all these things make me scare me a bit sometimes. These add calls, so all the incremental changes basically are still work in progress. Okay, cool. Unsupported constraints. Single variable greater than. Single variable greater than. Constraints not supported by the model. Yes, it is. Or it should be at least. Single variable greater than. Add constraints. Oh right, so we need to add these support constraints. Again, this is the weird way that MathOpt interface is doing dispatch. In the end, it's not too bad. I mean, looking at the MOIT unit tests, we are failing one. Okay, we are erroring quite a bit, so yeah, it's not brilliant. But we do have some things passing, so that's great. Okay, so what I wanted to say is MOI has this weird dispatch, including you have to explicitly say when you support something. So supports, in our case, we're gonna have to add some support constraints. So support constraints node, we want support constraint with saying that our optimizer support constraint of type function in set, and returning true out of this. And so this is going to be here. So my that supports constraint. So it's going to be optimizer. So single variable. Oh, I think I did it in the here. Wait. So I did it for this one, but not for. That's not great. Not for greater than. Union of less than my greater than. I think we could add my interval here. Is true. Okay. But I think I have this with interval somewhere. Yes, and we don't need that anymore. Okay, so let's rerun our test now that we say officially that we support it. So again, in normal Julia code, you will just define the function and that will be supported. You don't. So for example, you define plus for your number type and it supports being a number. You don't need to do much more. In the case of math-apt interface, you explicitly need to say what you support for the kind of bridge system that it intends to be, meaning that if you don't support a constraint, it will try to rephrase your constraint as something else, if it can. Unsupported, wait, we are now supporting it. Vector of variable, non-negative. Yeah, I don't support that, but that should be known already. Let's see what this is about. Yeah. So these things are terrible here. This is a macro generating test, and so you can't know where exactly the real error was. Delete non-negative variables. Okay, this one we will definitely. It's even surprising that CLP has it. Variable deletion. So this one we won't support. So yeah, all the variable deletions for a moment, or even constraint deletion, we don't support them. So it means if you want to delete a constraint, we'll just restart your model for now. So delete non-negative, that's done. So this failed, but that's fine. Solve with lower bound. This one is supposed to be okay, I think. Let's see, do we have, no, we close math-apt interface. Test. Do we have this somewhere? Yes. Solve with lower bound. And so let's see, I'm trying to see here what could possibly go wrong with that, with our model, because this seems like things we're supposed to support. And the error was, let's see what the error was. Yeah, it's getting a bit too big now. Alright, yeah, this needs to be way smaller if I want to see something. Unsupported constraint. So this is wrong. Single variable in greater than, we are definitely supporting that. You know what? Let's add a test for this. Test MOI that supports constraints. So for our optimizer type, single variable So for set in my dot less than 3.0, my dot greater than 4.4, my dot interval 2. So I don't care much about the values here. I just want to check if my constraint types are supported, and this goes with support constraint here. So I want this to pass, but I'm not sure this is going to be okay because the rest of the tests are failing. So I'm just going to run this directly. Oops, nope, I don't have HiGHS. No, I don't have test loaded. I have something that I don't support. Single variable. Oh, yes. Single variable needs something, so I'm just going to pass it x1 here. Oh, and my that this is not my, this is set. Right. Better. Okay, now everything is passing. So I do support this test, which means that I'm not supposed to get an error above. Let's try to rerun these and try to understand. So this is failing here. I'm gonna try to load this, but I think it's gonna error because of names in the test. Otherwise, so this thing here, MYU load from string, is a bit of an alien utility function. It's used to, when you have a model that doesn't support incremental changes, then you can load directly another model into your solver from this more or less standardized, almost official string format that's used in Math.out interface. Okay, so we are failing quite a bit. So model is going to be HiGHS.optimizer. Config. No. Config is going to be config. Did I not define that? Yes, okay. Config. Then if I copy this, const MOIU. So this might fail because I don't support constraint name, but now if I do the same with anonymous constraints, this should work. Wait, what? So I'm not sure how to do it then. Oh, it always needs a name? Huh. Well, that's a bummer. Well. So we can't use this, meaning, yeah, we're gonna have to rely on these not so great tests and what they're providing as an output. Yeah, otherwise I could just try to manually load this model into an HiGHS model and see what happens. Yeah, this requires constraint name anyways. Solve with lower bound requires constraint names, okay. Now I'm fairly convinced of it, so we should not bother too much. Do I have a test open? Yes. Where is my unit test? Yes, unit test here. So I'm gonna remove this one, which requires constraint names. Even though that was not very explicit, I mean, the error message we got was fairly hairy and hard to get, so I hope we can maybe make it better in the future. Requires constraint names. Well, that seems better already. Okay. Unsupported constraints greater than. Why is this blocking on that? Solve single variable obj. Okay. Yeah, I think I'm gonna try to remain in this single terminal for everything. Julia, math-opt interface, my cd src test. And I'm looking for this function. Unit test objectives 1. Okay. So why is this one failing? Yeah, again, it requires constraint name. I think we should really get constraint name at some point. It's weird that the bridge is not doing it itself. Anyways, main objective X, and then we have this. Maybe we can try to manually load this and test the functions just to see are we good on it or not. So our model is that, and then so let's first get our model ready. So O is an optimizer. We add a variable X, and Y add variable O, and we add variable singular. And then my that add constraint. So X, and X is so O, X, and my that greater than 1.0, and that's going to be constraint 1. Okay. And then we add an objective, so set objective sense. So we minimize min sense, yes. These warnings of development always make me sweat. And so we minimize this objective, which is just X, and so we should end up with an objective value at the optimum of 1. Nothing too serious here. Set. Oh yeah, the set method for the objective function is super heavy. Objective function, you need. This is parameterized by the type of objective function, and I think we only support scalar affine type, which is going to be way worse. Float 64, so you need to tell it here once, and then to provide the function itself, scalar affine function float 64, and then so this is the terms, my scalar affine term. So first comes the coefficient, which is in that case 1.0, and x, which is the index, and then to that we add the constant term on the objective, which is 0. Oh, alright. This I should not provide the type, but an object of this type. Yes, perfect. We changed the objective. It worked. This really should be worked on, how objective functions are expressed. This is really way too heavy. Okay, so we have this part, and this part. So now we can try to see if we can. So it's not C1, it's C, this constraint, and then we're just gonna copy the test to see if the test works. I think config is defined. Yes. Oops, that's MOIT. Oh, we don't support termination status yet. That's right. Well, this is not a big deal. Config. That's solve. False. Config. False. And then so I'm gonna rerun these tests with config. Okay, it's not doing anything, so I guess the test passed. There was no error, so that's great. So now I know that the error that was happening was that my test requesting the termination status, which is pretty essential. Basically asking how well did my optimization go? Did it error out? Did it stop at some point? Is it infeasible or is it unbounded? That's the main point, the main thing you can ask. Okay. So I hope everybody is doing alright on your side. On my side, I think I'm not gonna stream more for too long, otherwise, well, people are gonna get bored. And also, I don't think I'm gonna have much more to add in that case. So getting back to the test, if I scroll a lot here, I don't think I'm gonna be able to fix all of them, because they might all have the same problem, which might be lots of things I don't support. But at least with this I can say, okay, I have these tests, my objective is to have as many as I can passing, and for this I'm gonna need that, this and that. And I guess the first thing is maybe I should, if I say set config to solve, this might already be a bit better. So because I don't support termination status, but if I don't solve the problem, I'm not gonna run into that. So config is basically saying, when I test the problem, do I just set the problem and verify that the structure is correct, or do I also solve the problem and verify that my solution is correct, that the solver is spitting out the solution I'm expecting? So I think this is going to reduce my problems by a lot, but I'm still going to get errors for constraint names and stuff like that. Yes. The weird thing is getting things like this, it's very uninformative. MOI single variable not supported, single variable in greater than not supported. It's just odd because it is. So I'm not sure what's happening there. So let's see if we have a table of stuff. We have less errors, so that's the great thing. And some of them are not testing, but it's fine because the test is just not to error out. like be able to build your problem without spitting out any error, which is by itself a test. Update dimension. Okay, well, I guess some of it will require names, stuff like that. Yeah, constraint name is the big next thing, I guess. So I'm still not gonna use this here. So I'm gonna should I just comment it out? Yeah. So I comment this one out and hopefully remove the comments one by one in the future. So instead of, so this is basically an array of things that are not supported. Oh no, this is removing the comments I wanted to stay. So this array here is an array of tests that are not supported by the solver, and you basically add them one by one. But what I'd like to do is do the opposite and add the instead of removing some that I don't support, add some that I do support, and then add them one by one until I'm done and until everything is fine. So yeah, this will require a bit more work, but I think that will be for another stream. If you have some question in the last, let's say, 5 minutes until 9 here, just shoot and ask them. And yes, on optimization, on bridges, on MATLAB interface, JuMP, on the solver, feel free to ask. Otherwise, yeah, in 5 minutes, let's say we'll finish this. Yep, thanks for being there, Rick. Yeah, thanks for your questions too. Yeah, and yeah, for the others, yeah, I hope to see more Julia streams in the future on either Twitch or YouTube or anything. Seeing more content and how people are doing incredible things, new high P packages and so on. Yeah, I guess the last thing here would be prints. Yep. Prints for one side inequalities. One-sided inequalities on columns only, because we didn't do rows. Cool. So pull request is on its way. Yeah. Yeah, I'm not sure what the test diff will be in that case. If we're gonna have much loss coverage or increased coverage. I did a fairly focused job on coverage this morning, so this should be already quite well. This means I have more chance now to decrease the coverage than increase it. Yeah, let's see. Okay, I guess I'm not gonna wait for the whole thing. I said 5 minutes, it's now 4, so yeah, if you have questions or anything, just shoot. Yeah, otherwise see you next time. So I hope to do some more streams on maybe the same thing before rows, so columns instead of columns of the problem. Maybe add these constraint names also. So constraint is basically one thing I've really not touched much on this. So yeah, that's gonna be one of the black beasts to work on for future development. So yeah, I hope to see you next time, and yeah, take care. Bye.